Okay, here we go again with another great video by Jungle Jargon. So, we got issues. We got issues in cosmology. And let's just go ahead and get into it. We'll go to the paper and I'll begin to explain the problem from there. So we're going to add this, add that. And then we are going to the paper. This is Cosmology's Blatant Distance Contradiction. Okay, this is revised from the previous video that I did on this paper because it's very important. So, when you look into outer space, you can look out and see galaxies until they become too redshifted and you can no longer see them. The same is true when you look towards the black hole. You can look and see into the black hole until it's redshifted beyond what we're able to see. So there's a problem there. It just means that there's two distances limited by the redshift as to what we're able to see. The problem is they have two very different ages for these. You have 13.8 billion years, light years away. That's a distance. And you have 26,000 light years to Sagittarius A. Now, the problem with this is they're both the same distance. One is said to be 13.8 billion light years. The other is said to be 26,000 light years. And turns out they're both the exact same distance. Because when they took a picture of the surrounding glow of the black hole, we could only see into the black hole as much as what is allowable by the redshift. And yet they have these two different distances for both things that are. And if you understood that looking toward Sagittarius A, distance is contracted, meaning there's a whole lot more distances between here and there, a whole lot measures of distance between here and there, adding up to a whole lot more distance. The converse is true when you look toward distant galaxies that are redshifted. In this case, you're looking through the void of space where distance is expanded, so there's a lot less measures of distance between here and there. And so obviously light is going to arrive from those distances a lot faster than it would looking the other way. Because we have what's called the causation rate determined by both the measures of time and distance. Because when you look toward a galaxy, time runs by faster, passes by faster too. Now, the reason why they arrived at such different ages is because they have what's called a flat space-time manifold. It's called Minkowski's flat space-time, which is an assumption. It's never been measured or anything. But If it wasn't for that assumption, they would be able to know that the limit of vision determined by redshift looking one way is the same exact distance as the limited vision due to redshift that you have looking the other way. So if they knew that, they would understand that, well, yeah, the flat space-time is of Minkowski is wrong, because space-time requires matter, mass, and gravity. So let's just go ahead and run through the paper real quick if we can. Standard cosmological model's assumption of uniform flat spacetime, that's Minkowski's flat spacetime, and the constant light travel metrics lack empirical basis or observation, leading to erroneous distance estimates. 26,000 light years to Sagittarius A, and the 13.8 billion light years to distant galaxies. We propose that space-time requires matter, mass, and gravity in interstellar and intergalactic voids. Time accelerates and distances expand, enabling light from redshift-limited points where light becomes too redshifted to observe. So you're looking both ways. Both ways, light becomes too redshifted to observe, both towards Sagittarius A and distant galaxies to reach Earth in under 6,000 to 7,000 years. So this is how I believe that the universe can be 6,000 to 7,000 years old of proper time. This is going by our rate of time, of course, while maintaining C. So if you're looking toward Sagittarius A, time is slowing down and distance is contracting, meaning the causation rate is slowing down. So it averages out because you're looking all the way to where you can't see anymore because of redshift. Because in the center of a black hole is basically infinite anyway. But they have this estimate, this measure here of 26,000 years, light years, which is not possible. Because when you look the other way toward a distant galaxy, it's you can see the galaxies until they're redshifted out of our ability to detect. It's the same distance. It's the same distance. And they both allow for 6,000 to 7,000 years proper time while maintaining C. It's not that the speed of light is changing, it's that time and distance change due to the amount of gravity. These points, despite vastly different distances, are equivalently affected by void-dominated spacetime. This explains superluminal motions, spiral arm dynamics, and JWST redshift anomalies. Well, when you're looking both ways, it has to be the exact same distance. Like Earth appearing flat locally, but round on a larger scale, gravitational effects dominate on cosmic scales. So it's not like looking at a squirrel or a rabbit in your backyard. You're not going to see a change in measures of time and distance. But on larger scales, between galaxies, you will see a change in the measures of time and distance depending on gravity because of the extreme changes in the amount of gravity. Earth's position near the Milky Way's edge supports a universe under 7,000 years, refuting the standard model's baseless assertion because, of course, we're seeing the outer edges of redshifted galaxies that are detected by JWST as well. The standard cosmological model assumes uniform flat spacetime and constant light travel metric. In other words, they're projecting our light and our measures of distance, they're projecting onto the universe where there's no gravity. We have gravity here. We have a certain measure of time and distance. You cannot project our measures of time and distance into outer space or toward the black hole. Okay, relying on unverified assertions like cosmological principle and Hubble-based distances without accounting for gravitational variations. This is the reason why both distances are the same distance. The distance to the farthest galaxy that we can detect by JWST is the same exact distance as we can peer into the black hole until it's redshifted beyond our ability to see, is the exact same distance determined by redshift. This leads to overestimated distances, 26,000 light years to Sagittarius A, 13.8 billion light years to distant galaxies, an initiated 13.8 billion year universe, or inflated 13.8 billion year universe. Observational lengths where light becomes too redshifted to detect occur in both directions, as I've been saying. Towards Sagittarius A and distant galaxies, suggesting these points are equivalently affected by space-time effect, not vastly different distances. We propose that space-time exists only with matter, mass, and gravity. Now, the assumption of flat space-time says that even with no gravity, the space-time manifold is going to be flat, the same flatness, which is another impossibility. It's another contradiction because without gravity and mass, you're not going to have anything to slow down time or contract distance, making or allowing for our existence. In interstellar and galactic voids, accelerated time and expanded distances allow light from these redshift-limited points to reach Earth in under 6,000 to 7,000 years, proper time, driven by differential causation rates. Different causation rates. Physical processes per unit time, like Earth appearing flat locally. It looks flat as far as we can see. As far as we can tell, the Earth looks flat. But with a greater distance, it's round. Absolutely not flat. Gravitational effects dominate on cosmic scales. So you can't, just because time and distance don't change while you're looking at squirrels and rabbits in the yard, doesn't mean that it's not going to change on larger scales. It's flat where we are, but you can't project the flatness into outer space. Earth's position near the Milky Way's edge amplifies these effects, explaining superluminal motion 20 times the speed of light. Of course, that's because you're not using the correct measure. There's no such thing as greater than the speed of light. And they have measurements of 20 times the speed of light because They're using the wrong measures of time and distance to measure the speed. Same thing with spiral arms. They're moving faster because the causation rate is faster in the outer spiral arms. JWST redshift anomalies in a young universe. Okay. You could include things like Oumuamua moving faster than expected too, but they say that the radiation or the dust, whatever, is accounting for the speed difference in speed, which probably not. You have to take these difference in time and distance into consideration. If you're measuring 20 times the speed of light here, then your measurements on Oumuamua aren't going to be right either. Theoretical framework. Challenging standard model assumptions, because it was the same thing when they bumped an asteroid. The asteroid moved out faster than expected. That wasn't because of blasting its way or anything. The standard model is uniform flat spacetime assumption. Even in massless voids, lacks evidence. The cosmological principle and Hubble-based metrics ignore gravitational gradients, erroneously equating redshift-limited distance towards Sagittarius A, 6,000 light years, and distant galaxies, 13.8 billion light years, despite similar observational cutoffs suggesting comparable space-time effects. Void of space. In voids with negligible mass, space-time exhibits accelerated time and expanded distances, both of which combine for a greater rate of causation in the void of space, with intergalactic voids showing greater effects than interstellar voids. The line element is this, except with extreme temporal acceleration and spatial expansion, rejecting the flat space-time assumption. Okay. In the galactic space-time within the Milky Way, a radial gravitational gradient applies. Near Sagittarius A, extreme time dilation occurs. So you have this here instead of this. Outside the solar system, gravity decreases, approaching interstellar void conditions. Light propagation to redshift-limited points. For light from redshifted limited points toward Sagittarius A, I'm kind of liking this paper. I think it's pretty good enough to publish. And distant galaxies, Earth position yields this time, proper time. Proper time is this. In voids, distances scaled by K for Sagittarius A with 50, for galaxy 80. Okay. Galactic segments add minor time dilation. See, inside of the galaxy, there's still voids inside of the galaxy, but not as much, which accounts for the difference in distance. But it's actually the same distance, exact same distance, even though inside the Milky Way it looks like it's closer because of the contraction of distance and the slowing down of time. Everything looks closer. But you're approaching a black hole and everything is getting shorter and shorter and shorter, and slower and slower and slower. The redshift cutoff reflects similar void-driven space-time effects in both directions. Total of 7,000 years. Cosmological implication. The standard model's baseless assumptions inflate distances, ignoring equivalent redshift limits. JWST's redshifted galaxies and obscured views toward Sagittarius A suggest light arrives in 7,000 years by way of the voids. Superluminal motions of 20C and spiral arm dynamics reflect compounded void effects. The universe's age, standardly 13.8 billion years, which I could never understand anyways, because what rate of time are you using to measure the age of the universe? Obviously, maybe under 7,000 years, considering how wrong the estimates are in cosmological distances. The difference between 13.8 billion and 26,000 light years, which is exactly the same distance. So there's a problem there. There's a serious problem. Conclusion. Rejecting the standard model's unverified uniform spacetime, we propose that voids exhibit accelerated time and expanded distances, making redshifted limited points towards Sagittarius A and distant galaxies equivalently affected, with light arriving in under 6,000 to 7,000 years. This explains superluminal motion, spiral arm dynamics, and JWST anomalies. The Earth analogy of being flat locally and round on larger scales highlights the scale-dependent gravity, supporting a universe age of 7,000 years. So there you have it. It's actually a lot less than 7,000. Because I was asking Grok to explain the math to me, that's actually a lot less than 7,000 years. But there we got it. Hello, rebuke and reprove. How are you doing? One of these days, I hope to get back around and have some discussions with everybody. It's not always easy, but might be able to sooner or later, sometime is in the future. So I guess there we go. There we have it. We have a universe of 7,000 years old. And you can't yell at me for anything when the cosmological ages are so different for the exact same distance. You can't tell me anything about the age of the universe when you have two different ages, extremely different ages, for the exact same distance. And 26,000 light years is not that much different than 7,000 light years. And if you take in consideration the voids in between here in the stars and here in the center of the Milky Way, that 26,000 light years goes down to 6,000 light years easily, which is the exact same distance as the most distant galaxies that are redshifted out of our ability to detect. It's the exact same distance. Anyway, there you have it. God bless everybody and take care. Have a great week and stay close to the truth. Stay close to God and you will never be disappointed. Never, ever. God bless everybody and take care. And pray without ceasing.